Hello friends, welcome to Wise Things IoT. This is Bappa and today we'll talk about a very important topic in IoT that any IoT practitioner who deploy a project at field will have to face is the last mile travel of IoT. So we'll not only talk about the problem, we will also look at the solution, how an integrated gateway like a LoRa-WiFi gateway can help in such situation. And we will not only do the theory, but we'll also have a look at a LoRa-WiFi gateway in action and we'll see how this works. So let's begin. So let me first explain what do I mean by the last mile of IoT. Okay, so let's take some example. So say in a home automation or in a building or factory automation, the gateway are invariably placed in building, factory or your home. So it is difficult to create a communication with the peripheral things like this garden lighting or maybe the garage door or a camera mounted on your boundary wall or this cooling tower fans which are fitted on your rooftop. So because of the distance and many barrier in between, it is difficult to say create a reliable two-way communication with them. So in such cases, LoRa can help a lot because LoRa can work up to a great distance and even when there are barriers in between. So another situation like say in this warehouse, so they are smart pallets, so they need to send data to the cloud, and also the smart meters or instrument they need to send data to the cloud, but because of a bigger warehouse they may not find it very easy to send the data to the gateway because gateway is centrally located and these pallets may roam anywhere in the big warehouse, so it may be difficult to send the data up to the gateway. And in smart meter instrument case, normally RS-232 or RS-285 cabling is done just to reach the gateway reliably, but this is a lot of cabling and so this is not very convenient also. So this is where also LoRa can help. So now because we are not able to reach the gateway, there is a workaround. We can individually send our data directly to cloud. So this is a standalone topology, so where our nodes, edge nodes send data directly to cloud, and from cloud we populate our dashboard. But the trouble is to send data individually from each device, they need to have some GSM connectivity to the cloud directly. So the implication is actually the cost, because each of the node you will incur a data cost per month, like our mobile phone bills data plans, right? So this is one cost implication of standalone topology. So what is the workaround in LoRa-WiFi gateway? So in last mile or in carrier topology, what you can do, this node can send all the data to the common gateway. Because it is LoRa, you do not have the last mile problem. You can go up to 1.78 kilometers, so with a nice antenna setup. Okay, and from this common gateway, so now you divide your whole topology in two parts, whole ecosystem in two parts. So one side you have the last mile or aggregation, so that side you can use LoRa, Zigbee or mesh, like BLE mesh kind of things. Okay, Zigbee is also a mesh. On other side is the carrier side, where you can use Wi-Fi, GSM, NB-IoT, etc. and you can send your data to the cloud from the gateway, and from gateway you can create your from the cloud you can create your dashboard. So the thing is, you need to incur only one data plan cost, and so this is how your cost can be set. So now that we are done with the theory part of it, let us have a look at a practical demo. We'll have a live demo and see how this system works. So here we can see the last mile LoRa communication setup. So here is the integrated LoRa Wi-Fi gateway, and acting as a LoRa receiver here and receiving information from the smart pallet. So this pallet is the sender. Here you can see the LoRa antenna here. So this communication can work up to 1 kilometer and between 2-3 floors even. So that is the last mile communication. Here you can see it is receiving some data like 1.14 kg, that is actually 140 grams. So it is receiving data every minute from the pallet. So now what we'll do, we'll keep a rice packet, okay, of 5 kg, and we'll wait for the weight change. So here you can see the change. So the data is received by the LoRa receiver, and now once it has received the data, it will send the data through Wi-Fi to the cloud. Okay, so this is how this last mile communication is happening, and it can collect data from multiple pallets, not only from one, and whenever it gets some data, it forward that to the cloud. So here we are having a dashboard view of the same. So you can see when we started we had 140 grams on the pallet. only the gateway on top of pallet, and then when we keep the 5 kg rice packet, it goes to 5.14, then 1.5. So this is varying a little. So data keep coming every minute over Wi-Fi. So here you can see probably a data loss. So it happens in LoRa, so you need to take cover for that. So this is how this works. So the integrated gateway receives data through LoRa, so all the devices in the vicinity within 1 or 2 kilometer can be taken care of. So that is the last mile thing that it serves to, because you cannot have a Wi-Fi gateway, a Wi-Fi router everywhere. So you have it centrally somewhere, you keep a LoRa receiver there nearby, and you collect all the LoRa sender data on that LoRa receiver, and through Wi-Fi gateway send the data to cloud. So that way you save your cost for GSM in each of the sender node. So that was the last mile of IoT. Hope you found this useful and you liked the video. So please press the like button, and also please subscribe to the channel so that you get all the updates about any new video posting. So thank you very much. Bye. See you soon.